The prospect of living on Mars has transitioned from science fiction to a tangible goal, driven by advancements in space exploration and technology. This script delves into the multifaceted aspects of establishing human habitation on the Red Planet, examining the challenges, innovations, and future prospects. Mars, our planetary neighbor, has long been a subject of fascination and study. Its similarities and differences with Earth make it a prime candidate for human exploration and potential colonization. But the question remains, is it feasible for humans to live on Mars? Consider the implications of establishing a human presence on Mars. What would it mean for science, technology, and the future of humanity? The journey to Mars. Traveling to Mars is a monumental endeavor. The distance between Earth and Mars varies, but on average, it's about 225 million kilometers. With current propulsion technology, a one-way trip could take approximately 6 to 9 months. During this time, astronauts would be exposed to microgravity, cosmic radiation, and the psychological challenges of isolation. NASA and private companies like SpaceX are developing advanced propulsion systems to reduce travel time and enhance safety. Nuclear thermal propulsion and other innovative technologies are being explored to make the journey more efficient. Beyond reaching Mars, the challenge intensifies when considering how to sustain human life upon arrival. The Martian environment. Mars presents a harsh environment for human habitation. Its thin atmosphere is composed mostly of carbon dioxide, with surface pressures less than 1% of Earth's, making it inhospitable for human lungs. Temperatures can plummet to 125 degrees Celsius at night, and dust storms can engulf the planet for weeks. Radiation is another significant concern. Without a protective magnetic field, Mars is bombarded by cosmic rays and solar radiation, increasing the risk of cancer and other health issues for potential settlers. Reflect on the engineering and biological adaptations necessary to survive in such an environment. Life support systems. To live on Mars, robust life support systems are essential. These systems must provide breathable air, potable water, food, and waste recycling. NASA's MOXIE experiment has demonstrated the ability to produce oxygen from the Martian atmosphere, a promising step towards self-sufficiency. Life support systems. Water extraction from subsurface ice and the development of closed-loop life support systems are areas of active research. Hydroponic and aeroponic farming techniques are being tested to grow food in controlled environments, reducing reliance on Earth-based supplies. Establishing reliable life support is just one piece of the puzzle. Building habitats that can withstand Mars's conditions is equally critical. Habitat construction. Constructing habitats on Mars requires materials and designs that can endure extreme temperatures, radiation, and dust storms. Innovations include the use of Martian regolith to create building materials and the development of inflatable habitats that can be transported compactly and expanded on-site. 3D printing technology is being explored to fabricate structures using local materials, minimizing the need to transport heavy components from Earth. These habitats must also provide psychological comfort to occupants, incorporating elements like natural light simulation and communal spaces. Consider the architectural and psychological factors that influence habitat design for long-term space missions. Health and medical considerations. Maintaining physical and mental health on Mars is paramount. The reduced gravity, approximately 38% of Earth's, can lead to muscle atrophy and bone density loss. Regular exercise regimens and potential pharmaceutical interventions are necessary to mitigate these effects. Medical emergencies pose a significant risk due to the communication delay with Earth and the lack of immediate evacuation options. Therefore, medical facilities must be equipped to handle a wide range of scenarios, and crew members may require cross-training in medical procedures. Beyond survival, the sustainability of a Martian colony hinges on energy production and resource management. Energy and resource management. Reliable energy sources are vital for powering life support systems, habitats, and equipment. Solar power is a primary candidate, though dust accumulation on panels can reduce efficiency. Nuclear power offers a consistent alternative, with compact reactors under development for space applications. In situ resource utilization, ISRU, is a strategy to use Martian materials for fuel, construction, and other needs, reducing dependence on Earth. For instance, extracting water from ice deposits can provide both drinking water and hydrogen for fuel. reflect on the importance of resource independence for the viability of extraterrestrial colonies. Societal and ethical implications. Establishing a human presence on Mars raises questions about governance, legal frameworks, and ethical considerations. Who holds authority in a Martian settlement? How are resources allocated, and what rights do settlers possess? The potential discovery of Martian life, even microbial, would necessitate protocols to prevent contamination and preserve indigenous ecosystems. Ethical guidelines must be developed to navigate these complex issues responsibly. Looking ahead, the timeline for human habitation on Mars is a subject of ongoing research and debate. Timelines and future prospects. NASA aims to send astronauts to Mars in the 2030s, focusing on preparatory missions and technology development. Private entities like SpaceX have more ambitious timelines, with plans for uncrewed missions in the late 2020s and potential crewed missions in the early 2030s. These timelines are contingent upon technological advancements, funding, and international collaboration. The journey to making Mars a second home for humanity is complex, requiring sustained effort and innovation. Contemplate the collaborative efforts necessary to achieve interplanetary habitation and the role of global cooperation in this endeavor. The vision of living on Mars is becoming increasingly tangible, propelled by scientific curiosity and the innate human desire to explore. While challenges abound, the pursuit of this goal continues to inspire innovation and unity across disciplines and borders. Stay informed about the latest developments in space exploration and consider the profound implications of humanity as steps toward becoming an interplanetary species.